Okay, so right, yeah, I made some changes to update the hardware a little bit, and so before in the previous video, the I found out that when I was loading down the coils that were on the top section, the secondary output coils, which are actually below these trigger coils. These are these little ones at the top are trigger coils for to stop the pulse for the motor that moves the rotary system, right? Well, the generator coils are below that. Now what I've done is I've swapped them out. I've taken the generator coils that were down there and I put them at the back so that I can produce them. I can have them in. Oh, the light's not very good there. So now that if I just get that light out of it might adjust itself. But anyway, so I've got the main coils. I've moved them to the back. You can see the side there. Right, actually probably see better from the other side. So anyway, it's behind. Oh, you can't really because I've got my trigger RPM sensor there. But anyway, I've got the main coils at the back there. The main coils are at the front here, and I've put another set of coils in there just to occupy the space, and the new coils around, just so I could do some tests on those. The voltage isn't very good, but it produces a lot of current. It's about 500 milliamps shorted, but it slows everything down. Obviously, it's because of the problems. So anyway, so what I found by simply moving my coils to the back, and when I load the system down on the output, it's no longer affecting my current input, so I can fine tune the current input. I can have it down to 220 milliamps. I've had it as low as 210 milliamps actually, when I adjust the drive circuit, which is over there, so I can actually get the current down. But obviously as I lower the current, my RPM will drop, so because there's less torque. So I've basically kept it. I'm keeping it around 340 milliamps. But at least now, when I take the load off, things behave the way you expect them to behave. Because if I actually unplug the load on the meter, which is just take this, if I just take this lead out of the milliamp socket, which is there, so that it goes off, right, no longer drawing a load, we can actually start to see that the current will start to go down, which is what we should be seeing. So current consumption actually does start going down as it picks up speed. You know, it's a funny thing because normally when I do these tests and I do them, a live video stream them, things always don't work out for some reason. I don't know what it is, but at least it's doing well what it's supposed to be doing right now. So as I said, the drive current right now is only 230 milliamps, and it's actually very low. But remember, there's one other factor to be aware of. The voltage that I'm driving this at is 13 volts. Right, so I'm actually boosting the voltage up by about 1 to 2 volts. So the current that measures 230 milliamps on there, on my linear, on my analog meter, it's reading about 340. Mind you, actually I've just realised that it will read higher because, yeah, because this box here, this unit that's driving everything, that consumes 50 milliamps. So the box itself is obviously using 50 milliamps, so there's going to be extra on the other end, you know. Or actually it might be more than 50 milliamps, I'm not sure. But anyway, so without a load we're at 4,700 RPM right now. At that current, and the output is the yellow trace without a load on it, and the blue is my pulse drive circuit. So the blue is the pulse, and the actual pulse width at the bottom is inverted actually. That is the on time at the bottom. The off time is at the top. It's back to front. It's because of it's a PMP transistor I'm driving. So every time it goes low, it turns on the PMP because it's pulling the gate low. So you can see that the period is really quite small for the pulse. I haven't got it set up on the scope actually, but the whole period is 6.37 milliseconds. I haven't got it set up on the scope to show you the actual thing. Now let's put the load back on. Push that lead back in. Right. So yeah, and current's going back up on the input. That's the way it should be, really. Anyway, so not a lot to talk about really, apart from the fact that I have made some other changes to the circuit though. I changed my this diode over here that goes from, it charges this little capacitor which biases the gate on the MOSFET. It's one at the other end of the capacitor is going. This trimmer pot here is also grounded through this resistor and this diode through this circuit down to basically it goes through this wire until the opposite end of the circuit, because when this end goes low, when the AC switch is low on this end over here is high, so this end goes high, biases the MOSFET circuit and everything, while the opposite end is providing the low biasing for the capacitors to basically boost these capacitors to send a bigger pulse to the gate. So it's kind of a circuit anyway. So I made a slight change. I moved this wire here to the opposite end instead of having it going directly to the source pin, because I've got the Zeno across between gate and source, and I've got a capacitor. But this capacitor, instead of it going between gate and source, it's now going to gate and the ground that's on the opposite side, and it seems to work a lot better. I get a much better adjustment on the trimmers, and the schematic really is changed. So I mean, I can show you my schematic, but it's been changed since I drew it. So if I move over here a bit, so this connection here, I've basically snipped that. That's cut there, so that connection is no longer between there and there, but that Zeno is still connected to the source, which is down here. But and this capacitor here, and this diode and that capacitor over here, they're all basically go all the way to the other end, to the low side really, where the load is. So they go to the low side now, so it's kind of different than it was. Anyway, I'll have to draw up a new diagram. Well, I'll have to print out a new diagram and then show you that later on, because I haven't printed one out yet. But yeah, it's yeah, it's quite interesting. But yeah, as far as efficiency goes, yeah, not a lot to write home about there, I'm afraid. But we are getting some interesting results. Early today I had some problems, and I put my meter on here and I was reading at 1000 something volts. I thought, what the heck's going on here? And I realized, oh, it's RF. Yeah, RF is a problem, that I had an oscillation in the circuit, so I took that 100N capacitor out and I just left the 22N in, and that seems to sort it out. So having too big of a this little choke here, this little trachea, all that. I put that in there was to stop some ringing on the circuit, but it turns out that the ringing isn't coming from this circuit. The ringing is coming from my full wave rectifier over here with these capacitors across the coil. So yeah, that's what's causing my ringing problem. So anyway, I'm not worried about it as long as the ringing itself is not being generated on this circuit. There isn't really a problem to cure, you know what I mean? So it's just inadvertently creating a ringing problem at the other end, so that's something I can remove at some point. Take those yellow caps off the bridge rectifier circuit. What else is there? Well, if we all survive this coronavirus thing, apparently it's infecting all of China, most of China, and it's spreading to the United States, and it's also spreading to we think it's already in Britain as well at the moment, but it's going to be a couple of weeks before we know the results for that. This is something I don't normally talk about, but this is a pretty serious thing. If I mean, it might be hyped up a bit, I don't know, but you see, they're always talking about overpopulation, so maybe it is something that we need to be worried about. Yeah, but still, anybody out there, wash your hands when you go in public places, because you don't want to get infected. So if you go out in a public place, make sure you wash your hands when you come home. Don't touch your face. Also try to stay away from people who are sneezing and coughing and everything, because this thing's not very nice, and apparently some people have dropped dead in the street. That's what I heard. Well, whether or not it's true or not, I don't know, but it's better to be safe than sorry. Nobody wants to get pneumonia. Apparently it causes pneumonia, and it's very serious. So yeah, it's not something I would normally want to talk about in my videos, but yeah, you just can't be too careful. You don't know what this thing is. It's new. It's not very well known about. It's just been discovered. So yeah, I always expect the unexpected, and it always reminds me of that movie 28 Days, when a virus infected and killed most of humanity, and that thing could really happen. So we got to be careful, you know. And apparently if you do get sick, or if you do get it, you need to call your GP, and you need to quarantine yourself, stay away from friends and family as much as possible, because you don't want to infect them. Yeah, so you'll have to get people to send you food parcels through the letterbox or something. I don't know, it's not a funny matter, but yeah. Anyway, I just wanted to say that because I have been looking into it today, and it looks very worrying. I personally think it's worse than what they're telling us. I don't think they want to panic. They don't want people to panic, so they're actually trying to turn it down a bit, make it seem like it's less of a danger. But at the same time, they won't be airlifting people, their own citizens, out of countries if they didn't think it was that serious, would they? I mean, if it was a common cold or something, they would just say, oh, just take some aspirin. But no, they're airlifting people out of countries. Like, yeah, so that is costing them thousands of pounds. So there must be something much more to it than what we realise. I mean, you don't airlift people out of a country with private aircraft unless there's something seriously wrong. Trust me. I mean, they're not going to go to that effort for nothing. I mean, if it was just a case of taking an aspirin, then, or some medicine, cough medicine, I mean, they wouldn't be doing this. So yeah, anyway, I just thought I'd mention that because it's worrying. It is very worrying, actually. I mean, there's those who say, oh, it's fear propaganda, it's fear porn and all that, and but you see, when you deal with something this serious, it's better to be safe than sorry. You know, bottom line is, it's better to be safe than sorry. Because if you get it and you die, that's well, you only live once, don't you? So, I mean, sort of thing. Yeah, you only die once. Anyway. Yeah, just watch yourselves. Anyway, the project's coming along, and I was just going to say, actually, if I'm still alive in a month, we'll hopefully make more progress, but I don't know. Anyway, yeah. I'm going before I just get myself into trouble.